Do you feel the vibes?
Right, so in section 5, we are going to build on what we were doing with radicals and roots. So let's continue. Okay, so if you have real numbers a and b, okay, and an integer greater than 1, then if you have nth root of 8b, you can split up that root, right, and do nth root of a times nth root of b. So these two are equivalent, right? So if you have more than one thing under a root, you can split it up and give each its own root. Or you can go the other way. And if you have different root, same root, but, separate, you can combine them under one. Okay, so take a look at, let's simplify this one. We have fourth root of 32. So we have to prime factorize 32, and that'll give us 2 and 16, 2 and 8, 2 and 4, 2 and 2. Now, since the index is a 4, we have to group these by 4s. So those 4 come out as a single 2, and that 1 will stay under the fourth root. All right? Remember, it's a fourth root. It stays a fourth root. You can't change that. Okay. In the case of this one, I have a cube root of d to the 7. So what you have underneath that root is 7 d's. Now we're going to group them by 3s. So this comes out as a d. This comes out as another d. The other one will stay. So in the end, what I have is d squared cube root of d. Okay. Okay, this one. Okay, this is a square root. I have 3 elements in here. So let's start with the 12, right? 12 is 4 times 3, and then this is 2 and 2, right? So the 2 comes out, but the 3 stays in. Yeah? Mm-hmm. How about the c? C cubed, and is that it? Does that need an absolute value though? Yes, because it's even, odd. And then the d, right? So the d, we have 3 d's. How many will come out? 2 as 1 d, and then 1 will stay in. Yeah. Okay. Now, okay, so let's take a look at this one. The 27, right? Cube root of 27, how much? 3. Okay, now, let me write that here. Okay, writing this out, like y. I mean, that's fine if you have like y to the 4 or 7 or 9. But if you have like y to the power of 51, right? You don't want to sit there and write 51 y's, right? So instead, what we do is the following. We have we have the exponent 4 divided by 3, right? That's what we've always been doing, right? We're dividing the exponent by the index. This doesn't divide evenly, but I have 1 remainder 1. Is that right? So now this comes out, this stays in. So 1y comes out, and 1y, that's the remainder, it remains inside. I don't know why there's a lag. Okay? So let's do the z. I have 7 over 3. That's 2 remainder 1. So 2 comes out and 1 will stay in. So that's how we do it in short. Okay? All right. All right, quotient property of radicals. Again, we can split up like this, right? If you have a over b, you can do root a over root b. However, we have to rationalize the denominator. So now, if I have, let's say, 1 over root b, I multiply top and bottom by root b, right? We know this. So if I have 5 over root x, I multiply root x, root x. So here, look at what happens here. I get 5 root x. In the bottom, right, I technically, in the square root, I get x times x, which is x squared, right? I need 2 for them to come out. So that's why it comes out as a single x. So the idea is, initially, when I was here, it's a square root. That means there had to be 2 underneath it for them to come out. But I only had 1. I had some missing. And what I ended up doing is I completed whatever was missing. Yes? And that's how they were all able to come out. So now, what if it's not a square root? What if it was a cube root of x? How many total x's did we need in there for them to come out? 3, right? And if it was the 7th root, how many x's would we have needed? 7 of them. So you look at how much you have, and you have to add in the remaining. So you have to multiply by the root of b to the power of the difference of these. So let's take a look at an example. Here I have 3 over 5th root of 4. What is 4 really? What is it made of? How many 2's? 2 2's. So let's just rewrite that. 3 over 5th root of 2 squared. I really didn't do any math there, right? I just rewrote. Okay. I have 2 2's in there. How many total do there need to be? Okay, how many more do I need to put in there? 3. Okay, so what I need to multiply by is 5th root of 2 cubed, 5th root of 2 cubed. Now, 3. I have 2. I need a total. Okay, so look at this. Look up here. The exponent, this, right? It's the difference of this number and this number. 5 minus 2 is 3. Okay? So now, I have 3, 5th root of 8. Here I have 3, Here I have 5th root of 2 to the 5. Yeah? And that's why they can come out. So 3, 5th root of 8 over 2. Okay? Now, this step and this step are extra. I just did them in this first example for us to visually see what's happening. You can jump from when we multiplied in the red to the very final step. Okay, so let's do a couple. Yeah. No, you would still have to multiply. Yeah, but then you would have to cancel things. It would have worked, but then there'd be things to cancel out. Okay, so here we go. This one, we're going to split it up. So we're going to do square root of y to the 8, square root of 9x. So this is y to the 4. Yeah, that's from yesterday. Over. What happens to this 9? comes out as 3 root x. Now, I need to rationalize that root x, so I multiply top and bottom by root x. So now I'm going to get y to the 4 root x over how much? That's it, 3x. Questions? Okay, let's do this next one. Okay, cube root of 2 over cube root of 9x. Okay, I can't do anything with the numerator. Here, let's see what we have. 9 is really 3 squared, and I have x. Nothing comes out, but I still need to rationalize this. So I need to multiply this by cube root of some stuff. So let's look at the 3's. What do I need to put in here? How many 3's do I need to put in here? 1. And how many x's? 2. So cube root of 3x squared. So now I have in the numerator cube root of 6x squared over, is it just 3? 3x. Right? Okay. All right. So now, if you're told to simplify radical expressions, we multiplied these, these, and this. You have how many 3's in here? And then one more here. So if you multiply them under the cube root, you're going to have 3 3's. Yeah. Okay. So if you're told, right, simplify these radical expressions, right? What does that mean? Well, here's what needs to be done. You have to make sure the index is as small as possible when you are done. You have to make sure the radicand contains no factors that are nth powers of an integer, right? So you got to get rid of all the powers. The radicand contains no fractions, and no radicals appear in the denominator. All right? Okay. Okay, so let's take a look at this one. All right, so here I have a 5. All right, in this first cube root, is there anything I can take out? It's 10 squared, no, and not in that one either. So let's combine them all. Because it's 100, that's 10 squared. But it's a cube root. So this is going to be 1,000 a cubed. Now, this is 5 cube root of, 1,000 is 10 cubed and a cubed, right? So you can see now, you can take out a 10 and an a, and you get 58. Okay? All right, this one. I have coefficients which I can multiply. Then I combine the roots and I get 16 c to the 4 d to the 8. Okay. What comes out of this? Is that right? So we multiply it out, 96c squared d to the 4. Huh? Because it's not even odd. Okay. Yeah. Okay. So all right. While we're here, before I move on, okay, okay. So remember what we said here. The last one here is you can't have no radicals. You can't have any radicals in the denominator. So going back to 6.3, can you not move on and watch what I'm going to do here, please? Going back to what we were doing in like 6.3 or 2 with the inverses, right? So remember, sometimes, we would get an inverse that looks like, I don't know, like this, x minus 2 over 2, right? Okay, we no longer are allowed to leave it that way because this has a root in the denominator. If I split this up, this is x minus 2 over root 2, right? Write this down because you need to be able to do this. So how would I rationalize this? What do? Multiply by root 2 over root 2. So finally, that will be the square root of 2x minus 2 all over 2, right? So that's how we need to leave our answers now. It doesn't matter. That doesn't matter. It's just you can't have a root in the denominator. Okay. Yeah. Okay. Yeah. Mm-hmm. Correct. In the next lesson, we'll learn of other ways to do that. Okay. So this one, we're adding and subtracting. So we're adding and subtracting. To do that, we need like terms. That means the roots have to be identical. So like root 2 and root 2. So if I have a root 8, I need to have another root 8. That means I need to simplify both of these. So this is 4 times root 8. How does the root 8 simplify? 2 root 2. Plus 3 times, how does the root 50 simplify? 5 root 2. So here I have 8 root 2 plus 15 root 2. Now they're like terms, right? If I have 8 of these root 2's and then you have 15 of these root 2's, together, how many of them do we have? 23. Okay? All right, so we're going to do the same thing here. This is 3 times root 45, 3 root 5, minus 5 times root 80, which is 4 root 5, plus 4 times root 20, 2 root 5. So this is 9 root 5 minus 20 root 5 plus 8 root 5. So that is negative 3 root 5. So suppose you do this and you end with something like 9 root 5 minus 2 root 2 plus 3 root 5, right? Just combine the like terms, right? So just combine this one and this one, minus 2 root 2. That's it. Okay? Yeah. These ones? So, well, like the 80 or the 45, right? So the for sure way is this, right? So it's 3 root 5. But I also think to myself, does 45 have a factor that's a perfect square? Yeah, 9. 9 times 5. 9 is a perfect square, right? So root 45 is 9 times 5. And then the 9 comes out as 3 root 5. That's how I can do them. But doing this only takes like a couple seconds. So I suggest you do this. Now, if you get 3 root 5 and you're not sure if you did it correctly, to check, what's this number squared? 9. What's 9 times 5? 45. All right? That's how we do them. Okay. This one, simplify, means we have to multiply this out. So first, outer, inner, last. Okay, so let's go ahead and do that. First terms. Whoops, not there. So that's going to be 6 root 3. Outer terms, negative 2 times root 3 times root 3 is just 3. Inner terms, positive 9 root 5. And then the outer terms, negative 3. And then root 5 times root 3 is root 15. Okay, I was actually going to ask, does anybody have any questions? Okay. Jonah, did you have a question? Okay. Okay, so here, let's simplify. So 6 root 3, there are no common terms here, right? Minus 6 plus 9 root 5 minus 3 root 15. Not really. Okay, let's do this one. Okay, actually, why don't you guys do this one? Quickly. First, outer, inner, last. Go. Okay. So we did this. We got 71. You realize, right? This is A minus B, A plus B, right? So you could have also done it using our shortcut, right? Where you square the first one, you square the last one. What would that be? Oh, sorry. Oh my God, I'm sorry. Sorry, I wrote it wrong. It's A minus B, A plus B, sorry. Right? So you square the first one. you square the last one, and then just subtract, right? Minus in the middle. And that would have, had less steps. Okay. These ones, we have roots in the denominator. So what we have to do is multiply. Do you have a question? Okay. So you have to multiply by what we call the conjugate. The conjugate is essentially the same thing, but with the sign in the middle flipped. So if I have root 6 minus exactly, it's just like the complex conjugate, but with this. So instead of root 6 minus 5, I just have root 6 plus 5. You don't need to create it, right? Just flip that sign in the middle. So here, root 6 plus 5. Now, we create a minus b, a plus b, difference of squares, right? So what we're going to get here, okay, you know what, for the first one, let me just multiply it out. So we distribute this, 8 root 6 plus 40. And in here, if you forget that it's a pattern, just FOIL. So root 6 times root 6 is 6. The outer ones gives you 5 root 6. Inner ones, negative 5 root 6. Last ones, minus 25. These go away. So I have 8 root 6 plus 40 over negative 19. Now, we usually don't like the negative 19 in the denominator like that. So we distribute it to the top. And yes, I'm going to expect you to do that. Okay? It does, huh? Fine. Okay, can you guys please raise your hands if you're going to ask questions? Just so. Okay, this one. We're going to multiply by the conjugate. So the numerator, we have to FOIL. There is no other choice. So first terms, 6 root 3. Outer terms, negative 24. Inner terms, negative 3. Last terms, positive 4 root 3. Okay. The bottom. Even though this, what we did here, is correct mathematically, but again, in honors, we really do expect you to notice that there is a pattern and to be able to apply the pattern, right? The shortcut. So we're just going to square the first one, square the last one with a minus in the middle. So finally, I have here, when I combine like terms, 6 root 3 plus 4 root 3, 10 root 3, minus 27, over, what is that? Negative 13. So again, negative 10 root 3 plus 27 over 13. Now, again, convention is usually we don't like to have like just stranded negatives like this, right? So when there is a situation where one term is negative, one term is positive, books will usually write the positive one first and then the negative so that it's more compact, right? Like the negative is like incorporated into the expression. All right? Okay, questions? Are you sure? Did I answer it for you? Look at that. Okay. Right, this one. Okay, go ahead and do that one. Right? Okay, so this is it. You can't do more. So for these two, the coefficients are x and 1, and those don't combine. So you can't do any more. That's it. We're done. Yeah.
But could you do like x minus 1 in parentheses?
Yeah, but then you just get this back. Right?
But then it's
Then,
minus root x.
yeah, but it's not.
You get rid of x minus 1 on the bottom.
But then you literally just get. I mean, I guess. I don't know. This is also fun. Okay, so this one, this is a different situation because you have one square root. So we're just going to multiply by the same thing, x squared minus 4.
Yeah, just like
What's an imaginary number? So when you have, you cannot simplify this. This does not equal x minus 2. No. We cannot. If there is a plus or minus in here, we cannot simplify it. Okay? So let's do this and then I'll show you why. So this is going to be the square root of x squared minus 4 over x squared minus 4, and then we're done. Really? Okay, let's take a look at this for a minute. So suppose you have the square root of 25 minus 9, right? Okay, what's 25 minus 9? 16. So that's 4. But suppose you said 25 minus 9, oh, that's just the same as, what, 5 minus 3 when you take the roots? Then you get 2, which is not the same as this, right? So you cannot just take a square root like that, okay? All right, just like if I have like x plus 2 squared, it's not x squared plus 4, is it? No, right? There's another term. It's the same. That's the inverse of this. It's the same thing. You can't do it that way. Okay? I know. Okay. So, all right. So that's section 5. Okay.
Press start.